It sounds like I'm sort of right
Nah,
that.
man, you're wrong, man.
Look, stop.
You're wrong.
Whose side are you on? No, we're distinguished clouds. What nuance am I missing, or what more bluntly did I get wrong?
With all due respect, Dr. Tyson, it's pretty much all wrong.
Whoa!
It seems to me that you've sort of heard some things about the separation of charges in the clouds, and then now you're applying that to the ground.
Skies. And so the electrons collect. Now, if you happen to be under a thunderstorm, there'll be a lot of those electrons collecting locally. The electrons want to get back to the cloud, but they're really lazy. And so lightning, there's what's called a leader stroke that is exploring what path between the sky and the ground requires the least stress on the movement of these electrons. It finds the path, it's called a leader stroke. In the moment that leader stroke completes, the electrons surge back to the cloud, and that is the lightning bolt that we all see, that most people think comes from the cloud to the ground. But it's the electrons that had accumulated going from the ground back up to the...
I mean, the first thing we have to establish is the ground is grounded. The ground is like the solution for static charge. If you have static charge on an object and you ground it, it gets rid of the charge. It's true that raindrops could have charges on them, which would be static charge. Just like any object that you discharge by grounding, when the raindrops hit the ground, they get neutralized.
Oh, okay. So that's completely wrong.
Completely wrong.
Totally wrong.
Even if the ground is neutral, I get that.
But there's something else that happens. Let's say I don't neutralize it. Let's say I have a balloon that's full of charge and I just hold it above the ground. That creates an image. There's an induced image. We see positive charges on the ground that are an image of the balloon. That's very different. Those charges on the ground, we didn't actually add any charges on the ground. They're just an image. So that's what happens on the ground. Now, those images are very real. If that image gets very powerful, it can still produce a discharge, but it's not static charge.
I have seen actual video footage, high-speed film of a lightning strike where the lightning came out of the ground first and then pulled
discharges from the ground. Okay, like just say, imagine I have this balloon again. I'm never going to touch the ground, but that balloon, the charge gets more and more and more intense. It induces so much charge on the ground that the ground can produce a discharge.
Okay.
That's different, but that's different. The balloon can also produce a discharge with all the sparks on it, but one is an actual amount of charge and the other is an image. And you're absolutely right. There are such things.